Thank you for joining us here on Skilled, Safe, and Trailblazing. If you're responsible for training the next generation of lab professionals or looking to level up your own expertise, you're in the right place. My name is Jessica Martin, and I'm a lab training professional with a background in chemical education research and community empowerment. I'm here to dive with you into the real-world strategies, expert insights, and game-changing discussions that will help us develop lab professionals who are skilled, safe, and trailblazing. We're focusing on chemical sensitizers, specifically peptide coupling agents. Myla Kara is joining me today to discuss the regulations around chemical sensitizers and the practical takeaways for a lab. She is a certified chemical hygiene officer at Oklahoma State University who cares deeply about making sure everyone feels safe and supported while working in the lab. She has a background in chemistry, chemistry education, and bioenergy. So Myla and I recently had a great series of conversations prompted by a paper that came out in 2019. In this paper, an individual described how she became sensitized to peptide coupling agents during her time as a graduate student researcher. A link to the paper is included in the show notes. I was a graduate student researcher when I first read the paper, and it had a real impact on me. When I recently brought it up to Myla, she helped me see the paper from a safety professional's perspective.
I had so many questions about how the safety professionals responded that weren't answered by the narrative, while this paper gave me plenty of detail to think about. It said very little about regulation and structure.
And then you dived right into putting those pieces together. I have learned so much from you sharing that deep dive with me, and I thought, why not share the experience with our audience? This episode is about chemical sensitizers and about a case study on how we as a research community really learn all of the data that our regulations are ultimately built on.
And fair warning, by the end of this episode, routine way out is going to sound very different.
So Myla, what does it mean to become sensitized to a chemical?
Sensitization means your immune system learns a chemical like it's a threat. At first, you may not react. That's the induction phase. Your immune system is learning. Later, even limited exposure can trigger an extreme reaction. OSHA's own health hazard criteria explicitly point out something important. Lower levels are often needed to trigger a reaction after someone is sensitized than were needed to cause the sensitization in the first place.
So you can't just lower the dose. After sensitization is established, the only safe approach becomes avoidance.
Exactly. There are also two modes of sensitization to consider. Skin sensitization is an immune mediated allergic state. Later skin contact can trigger allergic contact dermatitis. Respiratory sensitization is an immune mediated airway response, classically occupational asthma. In some cases, severe allergic outcomes can occur with airborne exposure.
So is this different from a chemical being classed as an irritant?
Yes, irritation can happen to almost anyone at a high enough dose, and irritation goes away once the trigger is removed. There is no lasting impact. The person can still work safely with the chemical in question. Sensitization is very different because it's immune system learning. It persists, and when it is established, tiny exposures can cause big reactions, typically for the rest of a person's life. It is also not fully understood why one person can be exposed to a chemical for their whole lives with no sensitization, and yet Another person can develop severe sensitization after only a few exposures. It is one of the aspects that makes sensitization so challenging to identify.
So, if you've ever done peptide synthesis, you've likely worked with chemical sensitizers. Peptide coupling agents, such as DCC, HATU, TBTU, are useful tools used routinely in this field. From an occupational health perspective, they represent a pattern: low molecular weight chemicals that repeatedly show up in reports of allergy, dermatitis, rhinitis, asthma, and even anaphylaxis.
That pattern inspired Graham and colleagues to take a closer look at the peptide coupling agents that their researcher colleagues were using every day. They noticed that toxicology data and SDS classifications were inconsistent across suppliers.
That's really concerning since we instruct researchers to review SDSs as an important part of risk assessments for experiment design.
Right? So they worked on a strategy to fix that. In 2022, they released a paper with their findings. The paper is linked in the show notes. They evaluated 25 different coupling agents and they found that 21 out of 25 were positive for dermal sensitization, and 15 were strong or extreme sensitizers.
Oh, wow. So that means this isn't one problematic agent. It's not a rare exception. This is a hazard class.
Yes, and the paper also flagged other hazards that matter for day to day lab work. Irritation and eye hazards showed up across a portion of the group.
Which explains why early warning signs get dismissed. People think they are experiencing the impact of an irritant. They don't assume that immune sensitization is in progress. One more detail I love in this paper: they looked at hydrolysis products too.
Right, these agents can react with water, even during handling and cleanup. So they also examined hydrolysis products of these agents. And those products often carry irritation and corrosivity hazards too.
So, if someone's thinking, but I'm careful, I'm only exposed to a small amount very briefly, the exposure concern is more complex than that. Now, you've mentioned dermal sensitization being examined in this paper. What about respiratory sensitization?
Yes, important nuance. The strongest class level evidence in the Graham paper is dermal sensitization, not respiratory sensitization. But we do have human case evidence showing serious allergic outcomes with airborne exposure to specific couplers.
Right. In the paper we discussed at the beginning, that researcher experienced respiratory sensitization that was related to 3 different peptide coupling agents with which she was working, but not to other common ones.
Right. There is also a case report of occupational rhinitis and bronchial asthma linked to sensitization to HBTU and TBTU. Another report describing anaphylaxis and contact urticaria from airborne exposure to powdered HBTU. These papers are linked in the show notes.
So, what I'm hearing is that there is class level evidence strongly supporting skin sensitization risk across many peptide coupling agents, and case evidence showing airborne exposure can be associated with severe allergic outcomes in some workers.
Right.
This topic got me thinking about another story involving a researcher working with an as yet unrecognized hazard class: Marie Curie and radioactive elements.
A very commonly discussed story. Marie Curie famously died from ailments that were either triggered or aggravated by radiation exposure.
It seems like 2 issues increased Curie's exposure: the pride of the overworked researcher and lack of institutional support. Regarding the first issue, While Curie noticed many of her symptoms, she was often dismissive of her own health, asserting that it did not matter relative to the importance of the work. Her stubbornness about addressing her own health issues served as an example to others around her, likely delaying efforts to reduce exposure. The second issue was a shocking lack of institutional support. She did her early work with colleagues in a dilapidated shed with water leaks and poor ventilation. They were using harsh chemicals to extract from hazardous waste the radioactive elements for which she would become famous. Repeated attempts by the scientists to secure a better, safer working environment for this work from their institution were thwarted, even after this work brought home not one, but two Nobel Prizes.
Things have changed a great deal when it comes to radiation safety, but a lot of damage was done to individuals to get there.
Exactly. And now we are looking at another emerging hazard class, peptide coupling agents acting as chemical sensitizers. So, how are regulatory agencies handling this?
Well, think of OSHA like it has 5 tools you'll see over and over. Some are strong, some are not built for sensitizers. The first tool is HAZCOM 29 CFR 1910 1200, which we have linked in the show notes. This is the right to know system. In the US, it is the reason you have an SDS at all. It is the reason bottles have hazard statements. It is the reason labs do chemical safety training. HAZCOM requires 3 basic things. First, the hazard has to be classified. Second, it has to show up on the SDS and label. Third, workers have to be trained and have access to that information.
And sensitization is actually spelled out in the hazard criteria. Skin and respiratory are both part of the framework.
But here is the limitation, and it's a big one. HAZCOM is an information system. HAZCOM can tell you this can cause sensitization, but it does not force the lab to redesign the workflow. It does not automatically say use a balance enclosure or use closed transfer or this task needs higher containment.
Oh, I see. So it's like a warning label on a car that says, wear your seatbelt. Helpful, but it doesn't install the seatbelt for you, and it doesn't stop you from driving like nothing changed.
Exactly. The second tool for laboratories is the Laboratory Standard 29 CFR 1910 1450, linked in the show notes. That requires employers to develop and implement a chemical hygiene plan. That plan has to spell out procedures, equipment, PPE, and work practices that can protect workers in that lab. It also has to include criteria for control measures, special provisions for particularly hazardous substances, and access to medical consultation when certain triggers are met.
So HAZCOM matters, but for labs, it is only part of the picture. HAZCOM gives you classification, labels, SDSs, and worker information and training, and that is important. It tells people what hazards are present, but HAZCOM is mainly an information system, whereas the laboratory standard tells you what has to actually be in place to protect people.
Right. The two standards work together so that protective measures are in place to limit exposure to the hazards identified in the workplace, and workers know about it.
That makes sense.
The third tool is PELs, Permissible Exposure Limits. OSHA maintains tables of PEL values that we linked in the show notes. This is the tool people wish worked better for sensitizers. A PEL is supposed to be your clean stop line. If you are above this, you are in violation.
Ah, I see. But for a lot of specialty agents and a lot of sensitizers, you don't get that clean number. There isn't always a sensitization targeted OSHA limit you can point to and say, here's the enforceable threshold.
And even if you had a number, sensitizers don't behave nicely with averages. The exposure that matters might be a 2-minute moment. You weigh the powder, you tap the spatula, a tiny dust cloud happens. You wipe the balance, you toss the wipe. So a shift average can look fine while the actual exposure occurred during a single quick weigh out.
Yeah, I can see how a PEL alone is often insufficient for sensitizers.
The fourth tool is respirators. OSHA's Respiratory Protection Standard 29 CFR 1910 134 is actually detailed and strong if you implement the whole program. Medical clearance, fit testing, training, written program, all of it. This standard is linked in the show notes. But here is what happens in the real world. Respirators often show up after somebody has symptoms, or after a close call, or after enough people complain. For sensitizers, reactive is late. Prevention should start upstream. Contain the powder, reduce dust generation, substitute reagents when possible, and minimize skin contact and contamination transfer.
And wearing a respirator comes with its own health related challenges, which is one of the reasons why we focus so much on appropriate engineering controls. It is far preferable to reduce risks in ways that don't create other risks. Proper ventilation is always preferred over respiratory use where it is possible.
Right. The fifth tool is the general duty clause linked in the show notes. This is OSHA saying even if there isn't a specific standard for this exact chemical, employers still have to protect workers from recognized serious hazards.
Ah, I see. So it matters, but it's case by case. And it's harder to apply cleanly to slow, chronic, latent disease patterns like sensitization than it does to acute hazards.
Because with chronic disease, you are often arguing timelines, recognition, and proof. Whereas with a broken machine guard, it's obvious.
Exactly. Sensitizers don't announce themselves with one clear event. So, HAZCOM gives us the warning label. The laboratory standard gives us some structure. PELs are often missing, respirators are reactive, and the general duty clause is case by case. Which raises the obvious question, what if the warning label itself is wrong or incomplete?
Then everything downstream, SOPs, PPE, training, ventilation, gets built on sand.
And you mentioned earlier that Graham and colleagues specifically noticed the variability of safety data sheets for peptide coupling agents.
Exactly. If the SDS omits or downplays sensitization, the SOP gets built wrong, PPE choices are mismatched, ventilation is underestimated, training stays generic, and the prevention system degrades. There is evidence SDS hazard warnings can be inaccurate or incomplete, which undermines HAZCOM's foundation.
And that, for me, was one of the fascinating aspects to the Graham paper. They didn't stop at publishing this paper in 2022. In 2025, they did a webinar with the American Chemical Society, linked in the show notes, to bring more exposure to the paper with an audience it would heavily impact. And in that webinar, they explained that they sent their data to all peptide coupling agent manufacturers they could identify to encourage them to update their SDSs. And this is the part that really ties it all together.
Exactly. STSs are built on data, but if data is difficult to identify or doesn't exist at all, then the STSs are weaker. Since each company is responsible for producing the STS for each chemical they manufacture, they can end up looking different from one another depending on who is doing the building.
Ah, yeah, that means your control level can accidentally become a purchasing decision, and for strong sensitizers, that's not acceptable. So, how does the EPA come into play, if at all?
OSHA governs workplace practice, HAZCOM training, PPE programs, respirator programs. The EPA, under the Toxic Substances Control Act, TSCA, can influence upstream chemical risk management, but TSCA processes are complex and not a quick lab control mechanism for specialty reagents.
So, a chemical can be legal to buy and use. There may be no enforceable occupational exposure limit for the specific hazard, and your minimum floor becomes hazard communication.
Which is a thin floor for a strong sensitizer class.
Wow. Sensitizers are hard because they don't behave like normal hazards. Exposed people feel fine until the immune system learns the chemical. The sensitization is persistent. Tiny exposures can trigger symptoms later. Exposure can happen through multiple routes, such as dermal, airborne dust, and transfer between surfaces, and early symptoms can look like allergies or irritation.
And once someone is sensitized, prevention becomes containment and avoidance, not minor exposure reduction.
Oof, this is definitely a tough challenge. So, what can labs do tomorrow morning about this hazard class?
Start with the hierarchy of controls. Can you eliminate the sensitizers from your processes? If not, can you substitute something that reduces exposure? If not, can you contain the sensitizer in some way that reduces exposure?
So, you don't create that little powder trail through the lab.
Yes, no powder trail, no invisible dust cloud that follows you out.
All right. So, what about gloves? Because people always hear this and go, fine, I'll wear gloves.
Gloves matter. Choose gloves that match your solvent system. Change them frequently and assume the outside of the gloves is contaminated. Reinforce proper glove removal practices so that your lab members aren't undermining the whole point of wearing the gloves in the first place.
Right. And this is where you bring in the rules about what you touch with your gloved hands.
Exactly. If you are wearing gloves to handle these reagents, don't also handle your phone, your keyboard, your notebook, door handles, drawer handles, because otherwise you are just transferring coupling agent residue onto everything that you and your colleagues will later touch with your bare hands.
Okay, that makes sense. And you said cleanup is a big deal. Why?
Because cleanup is exposure. People treat it like after the hazard, but with peptide couplers, moisture can change what you are dealing with. Hydrolysis products can form. That's why Graham's group tested hydrolysis products because the stuff you wipe up might be a different hazard mix than the powder you weighed.
Ah, so cleanup needs the same level of containment and respect as the weighing step.
Exactly. Cleanup gets high risk handling rules too.
Mm. So, how about the symptoms? Because this is where people dismiss what is happening until it gets really bad.
Yes, you need an early symptom reporting pathway that's simple and not scary. If someone gets a new rash, new rhinitis, like sneezing, or runny nose, or any wheeze that lines up with coupler work. They should document the reagent and the task and report early to a supervisor or EHS.
Because you're trying to catch sensitization before it becomes permanent.
Exactly. For sensitizers, early action is everything.
So, when it comes to handling an emerging hazard class, are researchers today better off than Marie Curie?
Yes, in structure, we have hazard classifications, SDS systems, respirator standards, and all of these things now put pressure on companies and institutions to provide laboratory spaces that can protect workers and everyone else from exposure, even for emerging hazard classes.
While there are many challenges still, it certainly sounds like an improvement from Marie Curie's dilapidated shed.
Right. Sensitizers still get recognized late because early symptoms look normal until they aren't. The system works best when solid engineering controls are readily available. Training and reiteration drives the correct use of engineering controls as well as administrative controls and PPE. Researchers take notes and speak up early. Groups compare notes. Safety professionals respond in a helpful way. And publications trigger control changes.
And while we still have the pride of the overworked researcher with us, we also have conscientious researchers sharing their stories in an effort to help protect others. In this story on peptide coupling agents, chemical researchers published case studies of their own chemical sensitization. This triggered those doing research within occupational health and safety to perform a more systematic review. In turn, they shared that data with chemical manufacturers to improve the very SDSs that chemical researchers rely upon to design experiments more safely.
There are still many unknown unknowns out there, especially for those working at the cutting edge of research. Communication is key to keeping the scientific exploration going while reducing the harm it can cause.
A big thank you to Mila for that deep dive on chemical sensitizers, a tough but important subject for anyone working in research laboratories. Now we're curious to hear from you. Have you worked through challenges of working with chemical sensitizers with a lab group? We'd love to hear and share some real-world examples to help all of our colleagues face these challenges. If not, has this episode inspired you to start asking more questions about chemical sensitizer use in your labs? We'd love to hear about this as well. Let us know by either emailing us at skilledSafeandTrailblazing@gmail.com, commenting in our LinkedIn community, linked in the show notes, or leaving a comment on this episode. Thank you for all you do to develop lab workers who are skilled, safe, and trailblazing.
Skilled, safe, and trailblazing is meant for those working in labs or training others to do so. The information shared here is a starting point, not a complete guide or legal standard. We've done our best to use reliable sources, but we make no guarantees about accuracy or completeness. Always follow local, state, and federal laws and consult legal or safety experts if you have questions.